we are going to go ahead and investigate our tangent function and our inverse tangent function. So we have 3 periods of tangent below, and we can see that this function is many to 1 because we have many x values that will produce the same y values. So in order to find the inverse function, we need to restrict the domain of our tangent function. So we can kind of see some natural breaking points in our tangent function. If we go ahead and split the domain along our asymptotes, we can see that along these intervals, our tangent function will be 1 to 1. So every x value will be sent to a unique y value. So since we're splitting along the intervals, our endpoints are not included in these intervals. So we have -3 pi over 2 to -pi halves, -pi halves to +pi halves to 3 pi over 2, and so on. So just like before, we're going to focus on the interval that's closest to the origin, and that will be from -pi halves to +pi halves. So if we just look at our domain and range of this interval, we can see our domain goes from -pi over 2 to +pi over 2. And again, those are not included because we have asymptotes of these values, which means our tangent function is undefined at the endpoints on our interval. And our range for the tangent function is actually from -infinity to +infinity. We have end behavior along this interval, unlike our sine and cosine functions. So we will go from negative to +infinity. So remember, when we're looking at our inverse tangent function, our domain for tangent becomes the range for inverse tangent, and the range for tangent becomes the domain for inverse tangent. So we'll go ahead and indicate that on the next page. So we have our x values are going from -infinity to +infinity, which means our domain will be -infinity to +infinity, non-inclusive. And our range will go from -pi halves to +pi halves, also non-inclusive. So we have here our tangent function, and we can see it's not 1 to 1. So we need to restrict our domain between -pi over 2, and that's non-inclusive here, and +pi over 2. So now we just have one period of our tangent function. And just like all of our other inverse functions, we can find the inverse by reflecting the function over the line y equals x. So we remember from geometry that reflecting across this line switches our x and y values, which is exactly how we graph our tangent and inverse tangent function. So now I can go ahead and graph the inverse tangent, and we can see it has that reflection. And we actually still have the asymptotes too. So if I go ahead and graph the asymptotes in orange, I can see, I can see that our tangent function still has these restricted values, but now we have values of y that are undefined instead of like our tangent function where values of x are undefined. So we'll go ahead and graph this on paper now. And we are going to find the value of tangent for these angles. And you'll notice that these values are actually the same as our parent function. So we know the first and last values are the asymptotes, they are undefined. And -pi over 4 is -1, 0, 0, and +1. And remember, when we are graphing the inverse, we are going to switch x and y. So we switch x and y to get the inverse. And if I switch my first x and y, it looks a little funny because it's an undefined value, but I'm going to go ahead and write it as the strange ordered pair because I want you to see that When we write it this way, we can now see that y has an undefined value. So if we try to evaluate this function for y equals negative pi halves, we are not going to actually get anything. So our asymptote is now a value of y that is undefined. Instead of in our tangent function, we can see the value of x is undefined. Our next ordered pair will be -1, negative pi over 4, then 0, 0. That doesn't change, it's on that line of reflection. And then 1 comma pi over 4, and then we have another undefined value for y. So another asymptote, another horizontal asymptote. So we're going to go ahead and graph our tangent function. We'll first graph our horizontal asymptotes at negative pi halves and positive pi halves. Then we can graph our inverse function. So we have -1, negative pi over 4, 0, 0, and 1 positive pi over 4. And this is the graph of our inverse tangent function. Tomorrow we will look at evaluating using the knowledge that we have of our domain and range. We'll actually begin to evaluate the inverse trig functions.